Jimmy, it's Dan Abbott. I wasn't clear when we had our session what it was that you were confused about with this assignment. And so what I did was built a partial model of ChicksGarage so that I could show you how to go about answering these questions. First question you had was the one about horsepower, the size of the operators, and we covered that. HP stands for horsepower, and that's a measure of the motor size. Next one was how wide is the space between the overhead doors. So that's what the model would look like. And that's the frost wall that comes down below. When the garage is built, there's a floor right here, and that floor is 4 inches below the top of the foundation wall, or the frost wall. So the opening for the garage door includes the space from the bottom of that cutout to the underside of the header. And the header is there because otherwise the wall would look like that. And having each one of those studs spaced 24 inches on center, or sometimes 16, provides enough support to the double top plate for the weight of the roof. When you have a big opening like this and eliminate those studs, the weight of the roof is going to cause that top plate to sag. So these headers are put in there to stiffen that up. And these headers consist of 3 2x12s. Now we'll take a look at the plans and see how you know that. If you look at the floor plan on this, let's rotate that so you can read it. It tells you right here, well, first it tells you right here the size of the overhead door. 8070 means 8 foot 0 inches. Let me put the inch mark in there to clarify that. 8 feet 0 inches by 7 feet 0 inches. That means the width from the side of the opening to the side of the opening. So on this model, it's the distance from here to here. That distance right there should be 8 feet. So the height of the door, and that's the distance from here, the floor itself, up to the underside of that header right there, that one of those surfaces, that distance right there would be 7 feet. So if you know that's an 8-foot distance for the opening, and you know that the center of the opening is 8 feet from the corner, if you look at this, the center of that opening is 8 feet from here. That means that the center of the opening is 4 feet from here because it's the center. You know there's 4 feet from here to here as a result, because 8 feet to the center minus 4 feet for half the opening leaves you with 4 feet. The same is true on the other side. So since you know the overall length of this building is 28 feet, all you have to do is subtract what you know is the distance from the corner to the opening, the size of one opening, the size of the other opening, and then the size of the distance from the corner of the building back here. And that'll give you the width of the distance between the overhead doors. Now the other one was the height of the wall. And so in order for you to visualize what a wall looks like, I've created it here. And the wall itself consists of a sole plate, the part on the bottom, studs, which are the ones that go vertically up, and they support a double top plate. The double top plate is there to stiffen up the top of the wall so that the roof sitting on it has enough support. So if you look, what the question is asking you is, how far is it from the top of that double top plate to the bottom of that sole plate? That's the height of the wall. Well, the height of the wall is going to be dictated by the height of the garage door and the size of that header. So how do you know how big that header is? It tells you that there are 3 2x12s making up this header. And the 3 means that they're laminated. And laminated just means that they're all put together. So you see what they are. There's 3 of these side by side. They're nailed together, sometimes glued, and they make a very rigid, stiff header. Well, if they're 2x12s, that's the nominal size. The actual size of a 2x12 from here to here is 11¼ inches, 11.25. In other words, the nominal size is larger than the actual size. The same is true of the width. The distance from here to here, from here to here, that distance right there is 1.5 inches. That's the actual size of a 2x12. So you know, if we look at it right from the front, you know that the height of this right here, throw a dimension on there, the height from here to here is 11¼ inches. You know that each one of these is 1.5 inches. So you then know the distance from here up to here, which is 2 of those laying on top, is 3 inches. So the distance from the top of the wall to the bottom of the header is the width or thickness of the header, 11.25, plus the thickness of that double top plate, which is 3. So that tells you the distance from here to here. Now, how tall is the rest of the wall? Well, the rest of the wall, it has to be tall enough to support that header, so the opening from the bottom of the header to the spot on the foundation where you drive your car in is 7 feet. That's 7 feet high. Well, there's a drop right here of 4 inches, which means the wall actually starts 4 inches above the bottom of the door. So if you know that's 4 inches, and you do because it tells you that in one of the other questions, so that's 4 inches. Distance from the bottom of the wall down here where you actually drive your car in is 4 inches. And you know it's 7 feet from here to here. This part of the wall is 7 feet minus 4 inches. So the height from that point to that point can be determined from 7 feet minus 4 inches, and then you know that that's 11.25, then you know that that's 3. That's how you get the height of the wall. Now the other question you indicated you had was about the perimeter. It asked you how long the wall is, the total length of the wall, and asked you for linear distance. Linear means in a line, and so it's easy enough to find that out. You have 28 feet long here. Well, it's also 28 feet long here, and it's 24 feet here, and it's 24 feet here. So the linear distance and length of walls is the overall perimeter of the building. That's how many walls you have. That's what length of walls you have. So again, if you look at it over here from the top, that's the same plan you're looking at over here. There's my wall right there, and it sits right on top of the foundation wall. The part that sticks out is the footing. We'll talk about that in a second. But the length of this from here to here is 28, and you know the distance from here to here is 26. You just add them up. That gives you the length of the walls. And the last question you asked about is how do you do a takeoff, and that's number 21. Tells you the perimeter of the garage is supported by a 3'8" frost wall. Well, frost wall is that concrete wall right there that goes down into the ground deep enough so that when the ground freezes in the winter, it doesn't affect the wall. It also tells you on this question, back up just a little, tells you on this question that the wall is sitting on a 16-inch by 8-inch footing. The footing is this wide piece down here, and if you looked at it from underneath, you notice it's just a wider area of concrete that the entire wall sits on. The part in here is all dirt. It's just filled in with earth, undisturbed earth. So the footing measures the width of it from here to here, measures 16 inches. That's what that 16 means. The thickness of the footing is right here, that measures 8 inches. Well, the rule of thumb in building is that the wall itself is the same width as the thickness of the footing, and the footing is twice as wide as it is thick. So that's what you're going to use to calculate your volumes. Now to calculate a volume, you need to know the area of the entire part of the concrete you're looking for the volume of, and then the depth of that concrete. So you need 3 numbers to calculate a volume. And those 3 numbers give you the area to begin with, and then they give you the volume. Be careful that you're using the same units throughout. So if we're going to do the takeoffs on this, I'm going to convert first to feet, and then I'm going to use feet as my calculation, and then when I'm done, I'm going to convert cubic feet to cubic yards, because cubic yards is how concrete is measured. So just to make sure you can visualize the rest of this, it's a 3'8" frost wall. That means the height from the top of the wall, right there, to the footing that it sits on is 3 feet 8 inches. That means that the footing is 8 inches from here to here. It also says that the floor drops 4 inches from the top of the concrete, which is typical, so that the concrete wall goes up above the floor, and then the wall of the building sits on top of that so that it stays away from the moisture that might be in the floor. So we're going to just forget about that cutout, because you're going to have to pour the concrete anyway. And so The floor itself, though, right here is 4 inches down. But if you look at the size of the floor means it goes inside the concrete wall. So since it goes inside the concrete wall, I need to know what the dimension, just for the floor now, I need to know the dimension from here to here. I know the dimension from the outside of the concrete wall, which is out here, but I don't know the size of the inside of the concrete wall until I calculate it. So I'm going to calculate it, and I'm going to calculate, you see the wall itself is thicker than the wall of the building. So if the outside of the concrete wall is 28 feet by 26 feet, and you know it is because it tells you that in the plans, that means the inside of the concrete wall, which is the part where the floor is, must be the 8-inch wall on this side and the 8-inch wall on this side subtracted from the overall distance. So if the overall distance, and that would be right here, if the overall distance of that wall, by the way, we're looking down here at the footing, so when we're looking straight down at it, we're looking both at the wall and the footing. So just to clarify, the wall stops at the edge of this wood. The footing stops out here. So the wall stops here, but it goes all the way inside to here, so that distance from the outside of the foundation wall to the inside of the foundation wall is 8 inches. Same is true on the other side. So if we put a dimension and say, well, how long is this? That's going to be at 28 feet. The overall length of the wall right here, that's the 28 feet. And let's just get rid of that. That's the 28 feet. Now, the inside wall is 8 inches smaller on one end and 8 inches smaller on the other, so you have to subtract 16 inches from 28 feet. And the easiest way to do that is to convert either the feet into inches or the inches into feet when you do the subtraction. When you do that math, you're going to find that the distance from here on the inside is the following. Let me open up my calculator. So if I take 28, well, let's start with 16. If I take 16 inches and I divide that by 12, it tells me that 16 inches is the same as 1.33333333 feet. We're going to round that to 1.333. Now that's how many feet there are at 16 inches. If I subtract that amount from 28, say 28 minus 1.333, that distance, 26.667 feet, is the overall length of the floor. Now in the other direction, we don't have 28 feet, we have 26, but we're going to do the same thing. So if you look down here, 26.6667 feet times the other distance of the floor. When I say the other distance of the floor, I mean the distance from here to here. The outside of the wall, the concrete wall, is 26 feet. So the inside of the concrete wall, which dictates the size of the floor, is going to be 22.667 feet. So you find the area of the floor by multiplying that number by that number, and you end up with square feet. So you take the area in square feet, and then you have to multiply it times 4 inches. Now, 4 inches cannot be multiplied times feet. You have to convert the 4 inches into feet, or the feet into inches. So again, I go over and say, well, what is 4 divided by 12? And 4 divided by 12. So if I divide 4 by 12, I get 0.3333. So how do I find the volume of the floor? The area of the floor times in square feet times 0.3333 feet is going to give me the volume of the floor in cubic feet. So we'll hold on to that, and we'll get to the next piece. But then how do you do the calculation for the wall, and how do you do the calculation for the footing? Well, if we take a look, let's do the footing, and then if you understand the footing, you'll understand the wall. I looked at this from the bottom. Here's my footing on here. Let me just change the look of that color so that we can see what we're doing a little better. So now that's the footing right here. So what we need to find is the area represented by that surface right here, because we know the thickness of the footing excuse me, the thickness of the footing is 8 inches. But first we need the area. Well, this area is we're going to get this area from multiplying the overall length times the overall width of the outside minus the overall length and the overall width of the inside. So again, if we go to a smart dimension, that's 28 feet right there. I'm going to convert this to a drawing because it's a little easier to dimension a drawing in the software that I'm using. I'm just going to make a drawing from this assembly. Alright, so I've got the same thing now, but it's just in line. So this is the bottom of the footing, looking at it underneath. Now, if you take a look at that, because the wall sits centered on the footing, because the wall is centered on the footing, the overall distance or overall length for the outside is 8 inches longer than the width of the wall. Over here it's 8 inches longer than the depth of the wall. So instead of being 28 by 24, the footing itself is 28.8 by 24.8. So now you need to know what the inside is as well. Inside is 26. Inside of that is 22. Now again, this is the overall dimension of the outside minus the width of that footing, which is the distance from here to here is 16 inches. To go over here, there's another 16 inches. If you take the area of the outside and subtract the area of the inside, that'll give you the area of that footing right there. So if we know the area of that footing, and again, the area would be 20 decimal form, 28 feet 8 inches has to be converted to a decimal as well. So what we'll do over here, go to the calculator, say 8 inches divided by 12 inches per foot. It's going to 8 inches divided by 12 inches per foot, 12. So 8 inches divided by 12 inches per foot gives us 0.66666 feet. So this number right here, that number is going to be 28.667 feet times 24.6667 feet. And that's going to give you the area of the surface of the footing. Now, once you've got that area, which you'll get in square feet, the area in square feet times the thickness, and in this case the thickness of the footing is 8 inches, so 8 inches divided by 12 inches per foot, it's going to give us 0.666, we've already seen that. So when you get the area of the surface of the footing and you multiply that times 0.6667 feet, you'll end up with a volume in cubic feet, because squared feet times feet gives you cubic feet. Now the last thing here is, how do you then convert that to yards, which is how we measure concrete. To convert that to yards, and this is an example, that is not the right answer to this problem. You're going to calculate that by doing this. If, however, I wanted to convert a number like, as an example, 1,000 cubic feet into cubic yards, what I have to do is to find out how many cubic feet are there in 1 cubic yard. And it turns out there's 27 cubic feet in 1 cubic yard. And the reason is that 1 foot times 1 foot times 1 foot gives you 1 cubic foot, and 1 yard times 1 yard times 1 yard gives you 1 cubic yard. But in order to figure out how many cubic feet there are in a cubic yard, you have to multiply, go to the note. So we're going to do a calculation now. We know that there are 3 feet per yard. That's how many feet there are in a yard. So we also know that 1 yard times 1 yard times 1 yard equals 1 yard cubed, 1 cubic yard. If that's true then, and there are 3 feet in 1 yard, that means 12 feet, 3 feet times 3 feet times 3 feet must also equal 1 cubic yard. And if we do the feet and multiply 3 times 3 times 3, we get 27 feet cubed per yard cubed. Now, in construction in the United States, a cubic yard is known as a yard in terms of concrete. So we look over here. If we have 1,000 cubic feet and we want to convert that to cubic yards, you have to take a calculator and say whatever cubic feet you have, 1,000 in this example, divided by 27 cubic feet for every cubic yard. That's going to tell you how many cubic yards you have. So the number of cubic yards you have, if you start off with 1,000 cubic feet, is going to be 37.037 cubic yards.